If you follow me and you've watched my videos this week, you should now be happy with how to integrate algebraic fractions. We have a linear factor on the bottom. Today, we're going to look at integrating algebraic fractions. We have a quadratic on the bottom and a constant on the top. So we've done these three examples today. We're looking at this one. Now, let me give you a little clue for questions that look like this. If you do have a constant on the top, just a constant on the top like this, and a quadratic, you're going to be able to factorize the bottom. Okay, you just will. Because if you can't factorize the bottom, then it becomes an A-level further maths question, and you'd have to complete the square and use a trig identity to substitute in, but that's further maths, we don't need to worry about that. So an example of a normal A-level maths integral like this could be something like this, 2 over 2x squared plus 7x take away 4. Now we can factorize it. Now, if you can't be bothered to try and factorize that in your head, of course, you can just use calculator. A is 2, B is 7, and C is minus 4. Solve that. So we've got half, x equals half, and x equals minus 4 as our two roots. So we've got a root of minus 4, root of a half. So that means the factor, or the factors, if we have minus 4 as one factor, that means that x plus 4 using the factor theorem is one factor. And for the half one, that means that we have a factor of 2x minus 1. Because if you make 2x minus 1 equal to 0, rearrange it, you get x equals half. So now in a situation like this, we can now use partial fractions, which is the technique we need to use. So split this into partial fractions. So remember, when you have two linear factors on the denominator for a partial fraction, you just split them into two fractions like this with constants on the top. Now, what we can do, just multiply both sides by the denominator there. That's going to give us this there. And then we can just plug in values of x, which will wipe out these terms here. So let's plug in x equals a half. That's going to wipe out this term, and we'll plug it into there. So 2 will be equal to 0 plus 4 plus a half, which is 4.5, which is 9 over 2. So 2 is equal to 9 over 2b, times both sides by 2, divide by 9. B is going to be 4 over 9. Now what we can do is plug in x equals minus 4. That's going to wipe out this term, and we'll do the same thing again. So now we get b times 0 there. And then here we've got 2 times minus 4 minus 1. That's going to give us minus 9 there. And so that means 2 is equal to minus 9a. So a is equal to minus 2 over 9. So now then we can plug in these two values back into the partial fractions. So we've got minus 2 over 9 times by x plus 4. And then we've got here plus 4 over 9. So 4 over 9 times by 2x minus 1 for this one here. So now we have that this integral is equal to minus 2 over 9 times x plus 4, and then plus 4 over 9 times 2x minus 1, all with respect to x. Just going to expand the brackets as I've done here, and then now we can use video 1. If you've seen video 1 in this series, we can use video 1 to do the integration for both of these integrals here. So for the first one, we have minus 2 as the constant. We're going to take ln of the denominator, 9x plus 36. Differentiate the inside, we get 9, divide by 9. Next one, we've got this 4 plus 4, and then again ln modular signs, 18x minus 9. Do the derivative of 18x minus 9, that's going to be 18, to divide by 18, and then plus c because we have no limits. So we have minus 2 over 9, ln 9x plus 36. 4 over 18 is the same as 2 over 9, so you've got 2 over 9 there, and then ln 18x minus 9, and then plus c. So actually this one's quite nice because we have this factor of 2 over 9. So I'm just going to take out this factor of 2 over 9. So I've taken out this factor. I've put this term first because that's positive, and then I've put the negative term second there. So now what we can do is use rules of logs. When you take away logs, you divide the insides. So therefore you got something like this. Now if we just look at the inside here, we can actually factorize out a 9 both on the top and the bottom. So we end up with something like this once you factorize out the 9. Now they just cancel out. And so therefore you have this as a final answer. Just to re-emphasize, if you do A-level maths and not further maths, you would never be asked something like this, because on the bottom, this denominator, you cannot factorize that, because if you go to the calculator, A is 1, B is 1, C is 1, plug that all in, there are no real roots, you can't factorize it. So that would be a further maths question there. However, in A-level maths, they could actually ask a question like this, which looks harder than this one, but actually it's not as hard as that one there. So they could ask you a question where they do have a linear over a quadratic that you can't factorize. So tomorrow we're going to look at integrating linear expressions over quadratic expressions similar to that.